Students, agriculture is the key any day. So, I'm a farmer. I hope you are. I'm a farmer also, and I have a fish farm. I have a poultry farm. So some of the things I'll be talking about are things that I have experimented and I know they work. So, so we're talking about precision agriculture and applications. What is precision agriculture? Precision agriculture enables you to use cutting-edge tools to do farming. You would agree with me that agriculture has changed. How we do farming has changed. It's no longer you going with a hoe and cutlass and sweating under the sun. Now, a lot of things can be done through precision agriculture. A lot of things can be done using remote access. And some of the things I will demonstrate are things that we've done remotely. All right. So you see, like the area of remote sensing, the area of irrigation, automated irrigation, that you can control the amount of water, amount of fertilizer in your farm without physically being there. So these are the right source, the right quantity. All right. So these are some of the things that precision agriculture gives you. It ensures that everything is measured. And for instance, if you're growing cassava, you know what is the water nutrients needed to grow it at different stages. What is the NPK combination and all that. So you can automate the processes to make sure that all these things are done as at when due. All right. Next. So I'm going to show us two use cases. But before we get to those use cases, this is where we started from. Now today we talk about Industry 4.0. Industry 4.0 talks about the cyber-physical things. It is talking about connectivity. From 1.0, we were talking about mechanization, power, steam engine. From there to 2.0, where we're talking about assembly plants, assembly lines. 3.0, we're talking of automation. But in 4.0, we are talking about connectivity. That is why today we can talk about the Internet of Things, cybersecurity, artificial intelligence, and all that. And so this is where we are. So it is based on Industry 4.0 that I will show you what I want to show you next. Go on. So I have two use cases. Number one, these are the things I've talked about. These are the things you find, the technologies you find in Industry 4.0. Yes, go on. Go on. So, the first use case is called sensor-based aquaponics fish pond dataset use case. Now, in this case, we had a research, in fact, we had two different research funds. One from Lacuna Fund, USA, and one from TED Fund, Nigeria. We had two separate projects, which I'm going to describe. So we built, you see this box, it contains sensors. Sensors enable you to sense the environment, to get readings from the environment. In this case, it is water. So what we did was we wanted to know the amount of different physicochemical parameters inside the water, because the fish lives inside the water. So we did this with the catfish. We wanted to be able to pick, for instance, things like the amount of oxygen, the dissolved oxygen, the amount of the temperature, pH, amount of ammonia, nitrate, the turbidity of the water, and all that. So we built an IoT. IoT means Internet of Things. And what Internet of Things does is that it enables you to connect to different things. And you are able to communicate with those things irrespective of where you are over the internet. All right? Go on, so that you see. So this is the architecture of what we built. So when you look at this, we have what we call our microcontroller. which is is an embedded computer, but in a chip, just a chip. That chip itself is a computer. So you program it. And these are the sensors. Here we use 6 sensors. In the second project, we use 8. So you see there's pH sensor, there's nitrate, nitrite, ammonia, turbidity, dissolved oxygen, temperature. And then this is the pond. And all these things, all these sensors are connected to the pond. And they send data over the internet to the cloud that the readings. So what this unit does is to read all these parameters. For instance, they can tell you the temperature of the water at that point in time. So you send the data automatically to the cloud over a GSM network. Yes, go on. So these are some of the sensors we use. The one on the left is the temperature sensor. It's submersible. You put it inside water. And this one is the turbidity sensor. This measures the clarity of the water, because a lot of farmers, the problem we find out is that some of our local farmers, they do not know why their fishes do not do well, because they lack this. So, but with this, we will know using theoretical information and industry standard to know when the value, the reading in the water is no longer healthy, and then it advises the farmer to change water, right? So like this one, will sense how clean the water is, because when the water becomes dirty as a result of the feed, you know, we are talking about artificial pond now. How many of us have seen artificial fish pond? You have seen one? You've not seen it. What are you doing? If me in computer science, you in agric, you've not seen one. So you know, the water is in one place, it doesn't flow. So as you feed it, after some time the water gets touchy, it gets dirty because of the waste, their excreta, and the waste of the feed that they could not consume. Alright? So it is unhealthy for them to continue. They will not do well, they will not continue to grow. So this turbidity sensor will sense to tell you the value. There's a range. It could range from 0 to 100. But the less the value, the better. Are you getting my point? For instance, if you get 50, 50 is better than getting 100. 50 means it's clearer. Like the water we take is in the neighborhood of between 5 to 10 NTU, that's the unit of measurement, all right? So the water we take has to be clear, colorless and all that. So they also need clean water to survive. Okay, next slide. Now this is the setup. This is one of our setups. This one was the test pond one. So in our aquaponics system, we built vegetable on top of the fish pond. This we did within the university. We had two. One was in the zoo garden, the other was in the botanic garden. This one was in the botanic garden. The setup is still there till today. So we have a bed here, but this bed is soilless bed. So we grew cucumber on top. There's no soil. What is inside is just gravel and charcoal. All right. So we have. So here you see the sensor unit I showed you before. All the sensors are submersed, except the gas sensors that are on top that perceive gas from the water surface, ammonia, nitrate. So we have a submersible pump that we pump this water into this bird. All right. So the waste is manure for the plants. And as you do that, when it goes in, it filters the water and brings back clean water into the pond. So that way, we don't have to change the water all the time. That way we conserve water. So this is an aquaponic system, which is a combination of aquaculture and hydroponic. That gives you aquaponics. So we're able to grow this vegetable. We harvested the cucumber as well as the fish. So it's a very symbiotic system, all right? Very economical, that you can put the pond in even on your veranda. All right. Yes, next slide. So the sensor was sending this data. So we had 12 aquaponic catfish in one of the experiments, and then we worked with some farmers had one farmer at Enugu CK, we had one at somewhere in Barracks. So we set some of these ponds there, as well as the one we set on campus. And then we were monitoring their own also, all right? Okay, go ahead. Then these are the sensors. Like you have the dissolved oxygen sensor, the pH sensor, the rest of them. The purpose is to take this to AI, to use machine learning to train this data set to be able to predict what the weight, what the length of the fish can be at a given time t. So this way, a farmer will know the right combination, what's the right value combination for temperature, ammonia, nitrite, pH, dissolved oxygen, that will give the person optimum growth yield. That's the purpose of this. Continue. So this is the data set where we're receiving it in the cloud. So in real time you will see these scales, they contain date and time. So at any part, so what it means is that you don't have to go to your farm to know what is going on. You can stay in any part of the world and observe it. So we know if something went wrong, we will know from wherever we are. And we can call the farm assistant to check pond 6. Pond 6, the oxygen is no longer working, or the values there is not right. And the person will have to attend to it. You get the point? But we can take it up to another level, the level of automation, where we can automatically control the pond to empty itself and refill itself. That's another stage of it. Just go on. And so we built that data set and put it in the cloud in Kaggle data set. And at the time I prepared this thing about 5 months ago, we had about 1,772 downloads. A lot of people have been using it all over the world, the data set that we built indigenously. All right, next slide. Yes, so these are the people who have used our work. If you look at that graph in 2021, 2022, 2024, how much people have been using our data sets. Go on. And then these are some of the people who use our work. Then this is our machine learning model where we predicted the yield, all right, using the data sets. Go on. This is the data set, I'm telling you, there are 12 of them. And then, go back a bit. Yes, then with it, we built an app. After that app can be used by a farmer. All right? So, sorry, this is not very clear. The farmer can enter the values. He can read, maybe he has a temperature sensor. He can read the value of the temperature in the water, enter it there, the value of the dissolved oxygen, and then it will predict. And it will predict the length. This is the prediction of the length. It says 15.37, weight, 15.37 gram. Then for length, 4.7, okay, these are two different predictions. This 11.8 cm and 15.3 gram. Then this is another one. So a farmer can use this to know how his farm will do. That's precision we're talking about. All right, go on. So the next thing we are doing currently is this. We call it a computer vision catfish identification robot for predicting fish growth in aquaculture. I have a master's student who is working on this now. As we speak now, he's collecting data. What he's going to do is going to use this device. This device was given to us by NVIDIA. If you know NVIDIA, they produce GPUs and graphic adapters. When they saw what we did, they asked us to write, and we wrote. They gave us 10 of these robot devices for us to do this experiment. So I have my master's student currently working on this. So what this work is going to do is what we call automatic identification. Now it looks like magic, but now we are going to take photographs of the development of the catfishes from the different things, and we take the measurement, we take the weight, the height, the length, and put it as a data set. It's going to be images. what it means is that when we train this now using AI machine learning, all right, when we train this, when you bring a photograph, you take your phone, snap an image of a catfish in this app. The app will tell you the species, how old the catfish is, the one you snap to, and the weight and the length without you measuring it. That's what we want to do. Why do we want to do it? Go to the next page, you will see. The reason is because when farmers sell fish, they sell it in measurement by weight. And if you have tried to do that, you discover that to measure a live animal is very difficult. How many of us have tried that before? So to measure it, it will be frightening. But now what you need to do is just take your camera, snap it, put it to that app. The app will tell you the weight of that fish. Are you getting my point? It is not magic. It is precision agriculture. Finally, go to the next. The other use case is Internet of Things-based advisory system for watermelon farming. This also was a master student work. So this one, we had sensors that took soil measurement to check the amount of nutrients that are in the soil, and then to control the application of fertilizer at different stages of the growth of the watermelon. So I want to stop here because my time is up. So let's have questions.